Alright, so we're talking more about polynomials and zeros specifically. So if I said list the zeros, and I'm nice to you and I write it in factored form like that, what are the zeros of that polynomial? 2, -5, -1, right? 2, -5, and -1. My zeros are 2, -5, and -1. Because those are the x values that would make the polynomial equal 0. Those are the places where it would cross the x-axis, okay? What degree is this polynomial? 3, right? Because if I would distribute this all back together, what would be the highest power of x that you would see? A 3. So it makes sense that, first of all, there are 3 zeros, the degree would be 3, and so on. Okay? Nothing new so far. Pretty simple. Okay? List the zeros for this one. List the zeros of that polynomial. You got it. Go with what you know already. -2 is a 0, I agree. Positive I, negative I, right? Plus or minus, but you know those will always come in pairs. So I, negative I. And what else? 3. How many times?
4.
4. So we'd write 3 with a multiplicity of 4. So essentially 3 would be a 0 4 times. Nope, I just wanted to write that so you knew it was just referring to the multiplicity. Okay, no, you don't need to write your number small or anything there. It's a good question, but I'm just trying to show you that 3 is the 0 with a multiplicity of 4. Okay? What degree would that polynomial be? 7. Because if you would take this times itself 4 times, that would give you x to the 4th, but then times this one would give you an x to the 5th, times that one would give you an x to the 6th, times that one would give you an x to the 7th, or just count these up. 1, 2, 3, 4, 5, 6, 7. Okay? So that would have 7 zeros. The degree would be 7. You're not going to have to multiply anything out to the 7th power outside. Okay? Alright? Pretty simple?
Yep.
Okay, good. So, a couple of the problems today are pretty easy like this, where they'll give you factored form, and all you got to do is list the zeros. Goes pretty fast. Okay? When they're written in factored form for you, like this, it's really easy to tell what the zeros are. Okay? That's why, ideally, if you can factor stuff, that's the fastest way to get your zeros versus having to do all the finding them on the calculator, synthetic division, But got to have a method in case we can't factor. Okay? Alright. Now what I'm going to do is I'm going to ask you to write a polynomial with a given degree and the zeros that are listed. So I'm going to give you the degree and I'm going to give you the zeros. You need to write the polynomial. So this is just going to be a little bit of help with all this stuff. So the first one we're going to do has a degree of 3. And I'm going to give you just 2 zeros. I'm going to give you the zeros of -2 and positive 3i. Can you do it? Yep. But I only gave you 2 zeros. So therefore, so what's the third zero? -3i. Okay? Even though I only gave you 2 of them, you know these guys always come in pairs. We've talked about that already, why imaginary ones always come in pairs. Okay? So even though I only gave you 2 zeros, you can use the logic that, hey, imaginary ones always come in pairs, so -3i must also be a 0. Now I have all the zeros, so what are my factors? X plus 2, x minus 3i, x plus 3i. Okay? Now multiply those together. Okay? For the purpose of this, I'm going to go pretty quick through this. Alright? When I do this, I always multiply the ones with the I together, the ones that are pairs together. I get x squared plus 3ix minus 3ix, they cancel each other out, and then I get minus 3i squared, which is actually plus 9. Excuse me. It'd be minus 9i squared, which is actually plus 9, because I squared equals -1. Then I FOIL that out. Again, I'm going pretty quick here. That's going to be x cubed plus 2x squared plus 9x plus 18. Okay? Understand the logic behind that? Any questions on that?
How'd you get the positive 9 again?
Sure. So when I FOIL, I'll have a minus 9i squared at the back end of that FOIL, right? Mm-hmm. Okay? I squared is equal to -1. Oh. So really I have minus 9 times a -1. That would make it plus 9. Okay. That make sense? Mm-hmm. Good. Anybody else questions on that? Okay? Alright. Let's do a little trickier one. Let's say our degree is 4, and my zeros are -4, 5, and 1 plus root 3. Again, I only gave you 3 of them, but what must the 4th 0 be? 1 minus root 3. Yep, it's conjugate. Okay? Those irrational ones will always come in pairs as well. Now where you really got to be organized and neat. Okay? So this takes a little bit of work. So I got y equals x plus 4, x minus 5, x minus, if I minus this, both of them will become negative. So it'd be -1 minus root 3. And if I minus this, it'll be -1 plus root 3. Because you're subtracting that quantity, so you'd be subtracting the 1, and then you'd be subtracting a negative root 3, which would become plus root 3.
So we subtract it because the 1 is positive?
Well, we always subtract,
Oh.
right? X minus -4.
Just x plus 4. Oh, yeah.
X minus 5. Does that make sense?
Yeah.
Okay? Alright, if I was going to do this, I would probably multiply these two together, get that answer. Multiply these two together, get that answer. And then take those two answers and multiply them together. Alright? These two are pretty easy. X squared minus 5x plus 4x, so minus 1x or minus x, right? And then minus 20. Everybody good on that? Stop me and slow me down if you don't understand what I'm doing, okay? I'm going pretty fast, yes?
I think you might have said this already, but why do we do minus in both of the, for x minus?
Yep, that's all right. So, if negative 4 is a 0, what is the factor?
X plus 4.
Why is it x plus 4?
Because you subtracted.
Because you subtract it. It's always subtracting whatever the 0 is. Because, remember, if I were to plug in a negative 4 here, I need to get a 0, right? Okay, so that's why it's always x minus whatever the 0 is. So x minus a negative 4 becomes x plus 4. X minus a 5 is just that, x minus 5. X minus 1 plus root 3 would be x minus 1 minus root 3, because you're taking x minus the quantity 1 plus root 3. So that's kind of like, so that's why it's x minus 1 minus root 3, like that. Is that okay? Alright. Okay, so the first two, FOIL, that's pretty simple. The next one, okay? I'll write this out here, okay? I'll write this out. X times x is x squared. X times negative 1 is minus 1x. X times root 3 would be x root 3. Okay? Then I have to distribute my negative 1. So minus 1x plus 1 minus root 3. I'm running out of room here. Minus x root 3 plus root 3 minus 3.
Oh, I did do this.
Okay? Right? And most of you are probably canceling stuff out already, which is great. A lot of it does cancel out, and you get a fairly nice quadratic. Any questions on the multiplying there with radicals, guys? Questions on the multiplying with radicals?
That's just a lot to look at.
So I got x squared minus x minus 20 here. And then I got x squared minus 1x, so minus 2x. Plus x root 3 minus x root 3, they cancel each other out. Minus root 3 plus root 3, they cancel each other out. Plus 1 minus 3 gives me a negative 2. If it doesn't come out nice and you still somehow have radicals in there, you did something wrong. Okay? When you multiply this fun stuff together, okay? Being sarcastic would be fun. Okay? But when you multiply those together, or when you multiply the ones that have i's in them together, after you multiply, you won't have radicals and you won't have i's in them anymore. And if you do, you accidentally did something wrong on your multiplication or your addition. Yeah.
Okay, so you know the 1 minus root 3 and the plus root 3 towards the end?
Yep.
So did those root 3's cancel out then?
Yes, because
Okay.
I had a minus root 3 and I had a plus root 3
Okay.
after all my distributed.
So even though that root 3, the negative root 3 is technically with the 1, we could still cancel those out. Because like from the beginning it was like with the 1.
But I'm multiplying a trinomial times another trinomial.
Okay.
They're all separate terms,
Okay.
right?
Okay.
I know it's part of the 0, but if I just say x minus this, it's x minus 1 minus root 3.
Okay.
Because you're subtracting that entire quantity. So it's just separated into different terms.
Okay.
So then, yeah, there's no, that's not with that there.
Okay.
I mean, you could think of it as it is, but it doesn't really matter. even if I put parentheses there, you're still adding it, so you're still adding each term individually, and that'll eventually cancel out.
Okay.
Is that right? Okay, and then go ahead and finish it up. X to the fourth minus 2x cubed minus 2x squared minus x cubed plus 2x squared plus 2x minus 20x squared plus 40x plus 40. So y equals x to the fourth minus 2x cubed minus another x cubed, so I'd say that's minus 3x cubed minus 2x squared plus 2x squared, they're gone, minus 20x squared, and then I got my x's, 42x plus 40. Okay? So that's just working backwards from what we did yesterday. Yesterday I gave you this, you had to find the zeros. Today I'm giving you the zeros, you're finding the polynomial. Okay? Those two terms right there. Lots of steps, but nothing that's difficult. You just need to stay organized, watch your powers. When you multiply, remember, you add the exponents together. When you're adding stuff together, you don't change the exponents, you know, so negative 2x cubed minus another x cubed would be negative 3x cubed, things like that. That's where usually the errors occur. It's just kind of some simple algebra mistakes. Okay? But that's not a huge deal. Okay, it's more of, do you understand? I know the zeros, can I find the polynomial? And solve it. Okay? Alright. I won't go through this one and finish it, but I just want to make sure you understand the setup of it. And you won't have to do one usually at this degree. If I say a degree 5, and the zeros are 3 with a multiplicity of 2, negative 1, and 3 minus I, what would be our setup for that? We're not going to multiply it out, but what would be our setup? 3 minus I. You put x minus 3 to the power of 2, or if you want to write out two separate ones, that's fine. Okay, it doesn't really matter. If you were multiplying it out, I'm guessing you would probably write them separate so you could see it. Alright, so I'll go ahead and just write them separate. So x minus 3, x minus 3, everybody understand why there's two of them? It says multiplicity of 2, then what? X plus 1. Yep, that would be your setup. And then that would be a lot of fun to multiply together.
I would get so upset if you made us do this.
Okay? Alright, so that's really it as far as today goes. This worksheet that I passed out to you, it's from a different book. I know that our book does a great job. Some of the problems here are circled. I would do those circled ones. Some of the first circled ones are repeat problems from yesterday where you just have to find the zeros. If you feel like you know how to find the zeros and you feel really good about finding zeros, that worksheet we did yesterday, skip those at the top and move down to some problems that are more like what we're talking about today. Okay? You guys just got to be your own judgment of what you know. Okay? If you need more practice finding zeros, there's a couple here at the top where you got to find the zeros. Okay, but down here is more of the new stuff, and then on the back side there's just a few more that are circled. Okay, there's probably somewhere between 10 and 14 problems, somewhere in there. Okay, but that's your practice for today, or for the weekend really, and then we'll actually move on to, we'll get past this polynomial stuff, and we'll get into radicals and rationals next week.
So would this be on a test with radicals and
Yep, I put them all together.
Okay.
So that's why I don't even know if we'll get to a test by late next week. It'll be close.
Okay.